All right, we are live about a minute late. Thanks, folks, for tuning in. Right now, it's just me and Tommy from the UT team, although Seth just hopped on, and we got a few other folks coming in a second. Will be here. Yeah, so excited to see you guys. We have moved into preliminary assembly. Tom, I will have you sort of describe some of the new parts that you requested ordered. One little thing here that I somewhat facetiously put on there, not the most exciting acquisition, but could be an important one. These are our silicone caps that are exactly sized to, hey, J3NX, thanks for joining me, that go exactly on top of those chimneys. So we might not ultimately need these, but in the time being, if there's anything we want to seal up, to heat up and closed, I'll drop this off to you guys on Thursday. All right.
That'd be awesome.
And so we have kind of bad news, but then very followed by immediate good news, is that I'll show a picture here. We had, give me 1 second here. All right. So folks, remember, we were absolutely beside ourselves with joy with the arrival of our, oh God darn it, I can't see the pictures. With our, I'll just show this as a substitute. With our monoliths, those are not the ones, those are just representative. And we discovered that the CSPI, the cells per CPSI, cells per square inch, was not what we wanted. We wanted 100, and these were 25, and they were kind of flaking a little bit. And so I checked in with Kirsch from Clarity Tech to see, if he thought it was worth going with those. And he's like, it's not ideal. And then he very generously offered, without me even asking, he's like, let me just ship you 5 of ours. So he gave him the address. So he is sending those. So yet another awesome thing that Kirsch has done. And he said, once they arrived, as we've discussed, we can have a little special session here, hopefully streamed, but if not, where he'll run Will and the chemistry team through the ins and outs of how they do the wash coating and all of that. But the cool thing is exact same dimensions of the ones that we did pick up from Alibaba. In the meantime, Tommy, I think it's just useful to have those as a way of just seeing where they're going to sit within the chimney.
Okay.
And then we can just swap those out with, our preferred ones when we get them and wash coat them.
And so you don't want Will to wash coat them or put them in or anything like that. Like you just want them to chemical bond or anything like that. Yeah.
Well, what Kirsch was saying was not to use our very precious, $500 a liter PEI on that, but he has his own PEI. What I would say is that the material seems to be right. So we can use that for practice. If he wants to sort of practice wash coating with PEI he has and stuff like that, we can do that. Hey, Christina. Nice to see you.
Hello.
How are you?
Good. How are you doing?
Good.
Don't let me interrupt. Carry on.
Nope. Yep. It was just talking about how we got our various, parts have come in. Tommy just made a request, as we thought, once we had them, some of the sort of joining elements and little sort of bips and bobs that we need to connect things. So Thursday, as we said last week, Tom, we still think we are going to be putting some stuff together this Thursday night.
Yeah. So I'm going to look into. I can't stay for long in this meeting. I'm sorry. I have an exam in like times in like about an hour or so. I've got to do some last minute prep for that. But yeah, after my exam, I'm planning on looking into either ordering those for the same day or tomorrow before the meeting, going out and just buying them. Probably gonna go with the latter, just because they're all retail items. But the mass transfer team did a whole investigation on what they wanted to add to it. They talked about adding brackets to set the placing thing in place. They wanted a funnel to reduce dead air when we're cycling it through the whole system, just in case something goes wrong with the airflow halfway through and you get in a bad loop. And then they also requested, I'm drawing a blank on it right now.
I'll show here. You had a funnel.
The funnel, the brackets, and the, I have one more thing I'm trying to remember.
I'm opening it up right now. You had a temperature resistant epoxy syringe.
That's what it is, the epoxy as well. That's just for, we talked a bit about it, and I think the mass transfer team's the modularity of the system, especially based on conversation we've already had, in terms of this part, is a little bit more like they're trying to make that piece of the chimney into one modular part. So that part might be a little bit more like set in place. And in terms of switching out stuff, we switch out that. to make it modular and stuff like
All
that,
right.
based on the conversation we had.
Let me just open up the image here of
Sure.
the kind of the latest. Again, disregard the top part right now, but those two chambers on the bottom are important. So again, run me through what you were sort of just describing there. We got the funnel. The funnel might be just for the sequestration team with the Wollastonite. Is that right?
Well, no, so the funnel was discussing airflow into the fan itself. Based
Oh,
based on the like kind of loop phase, which is going to be our desorption phase when we close off the sides and kind of run it through the bypass tube. When we're running it like that, a concern was potential air, like since the fan doesn't cover up the entire chimney pipe, there was a concern about some of the air getting pulled back down around the sides. And we did some math for it. It's a low chance overall, but it's just rather get a guarantee on it, and make sure that we're being as efficient as possible.
okay. So what you would do is on that bottom chambers, you would invert like a Tin Man hat, basically the funnel, so that it funnels out to the fan, and then the fan pushes that air through to the narrower diameter of the heater.
And we would only need the funnel to go into the diameter of the fan. It doesn't need to be it doesn't need to come to a point or anything like that. So they're gonna cut the one we buy just real easily.
Okay.
And we should make sure it's heat resistant so it doesn't melt.
Okay. So this Thursday, do we want to kind of? It seems like a logical thing to do is to try to get that heating and fan chamber connecting those parts.
Yes, that's the goal.
Cool. And we can show that next week. Or next week is Thanksgiving, so we're not going to be on next week.
Yeah.
To it. Okay, that sounds awesome. Will, how's it going, man?
Going good.
Cool. So I did hear from Kirsch is sending me 5 of their 100 CPSI monoliths in the mail.
Nice.
So by the time we reconvene for this, but in the meantime, we can just use those monoliths we have just to sort of see how much space we need to put in, just seeing what they look like within the chimney. And then, because I think that the material is still right, the cordierite, like if you want to use it for testing or if you wanted to do a sort of a dummy wash coating with one, we can use those for those purposes. But we do have the Corning grade monoliths that are coming, and hopefully through that I can just get a supply from those guys and just avoid Alphabet altogether. All right.
Great.
All right, cool. So I'm excited I'll come meet you guys on Thursday. Really excited to watch, some of the assembly, as we were just saying, start with the chamber fan. We should also maybe talk through how we sort of drill holes into these for the what's it called, for the unless we can hook it onto the bottom, but we're gonna have to connect the bypass pipe. So
it's about the biggest thing for drilling is connecting the bypass tube, connecting the wires to different things, and then connecting drilling in the brackets if we go with that option.
Yeah.
The epoxy is going to solve most of those problems. The biggest concern I have right now is just making sure that I'm considering drilling those, making a plan for that part, and then drilling those parts, even drilling those holes in the side, even before we place in the things, because I would hate for us to place it in a certain orientation that it becomes difficult to wire it and stuff like that halfway through.
Okay.
So what we're probably going to do with Mesh Transfer Thursday is plan out exactly where to do it and then go ahead and do it.
Okay. One thing that just occurred to me is I wonder, these are pretty heavy duty here. It would be interesting to look at a situation where, as long as we seal them down, if we put the top of the bypass thing through one of these and then had one on the bottom where we had the same, so that you just have basically the bypass tube connected to 2 of these guys here. And
what are these guys? I'm sorry.
These are these very high heat, can get up to 200 degrees. Silicone caps that are fit exactly on top the chimney. So we could think, even initially for testing, before we decide if we're scared to drill holes into the side of the chimney, because that's kind of a point of no return, we could try to see if we wanted to put the tubes going on to these caps, so that you just put the whole bypass tube, they're connected to the caps on the top. You see what I'm saying?
Yeah, but I thought that the caps need to be in place while we're running the air through the bypass tube.
Oh.
Because that's during the desorption phase, isn't it?
Oh no. Well, the caps don't need to be in place. They can't be in place during adsorption, and then during desorption, you do put the caps on then, and that's when you want the bypass tube.
Yes.
Right. So anyway, I'll bring these tomorrow. We'll take a look at it, but as like
Sure.
an intermediary step, just to test to see if the airflow is good without, if we're scared to drill holes in the side of these relatively expensive chimneys.
Mhm.
At the time being, we could possibly do that. I have 8 of these guys, so we can screw up. We only need 2 of them if we use them. So
Mhm.
anyway, I'll bring them and we'll see how that works out.
Okay, sounds good.
Cool. Anything else on your side before I see you on Thursday? Oh, one other thing, Tommy, too, is just testing out like wiring up the heater and the fan. We just want to like get those working,
Yes.
in some type of way. So that might be something we even do before we should do before we connect them to the chimney pipe.
That sounds like a good idea. Yeah, we'll definitely bring the programming team up with us to work.
Okay. We need wire and stuff probably.
If you have some, it'd be great if you brought it.
I'll grab some. We'll see what kind of gauge is appropriate for these. It might say it in the paperwork.
All right. For sure. I'll look into that and I'll let you know what my plan is, whether or not I'm going to buy it in person or buy it online. Probably in person.
Okay. Sounds good. Great.
All right. Thank you very much, Chris. I'll see you all later.
See you, Tommy. Cool.
Bye. Bye, guys.
Will, any updates on your side or any thoughts or?
Yeah, I did have one quick question. So I guess this week was actually pretty busy for me. I didn't have a chance to do anything in terms of the chemistry for the monoliths, but my plan is to acid or base bath wash the monoliths, and I'm going to chop one of them in half as well, just to see what it looks like when you cut it in half, and see if we can work a little bit easier when it's like half of the size compared to the full one. And then I was going to plan to do a preliminary wash coat on one of the ones that are base bath. But I did have one request. Are you going to go like purchase any stuff like from Home Depot anytime soon or anything like that?
Well, Tommy was going to go. 2 of the things that he wanted, that both the brackets he wanted and the epoxy syringe are both at Home Depot. I have a Home Depot literally like a half a mile from my house. So
Okay.
If you have particular things you want me to go pick up while I'm picking up my son from school or something, I could do that.
Okay. I was just wondering because one of the things I do need is probably some kind of scale. So maybe it could be like anything like to weigh yourself even to be able to measure the monoliths. I don't know how much they weigh. They're kind of heavy, but I'm not sure if like a regular scale that's like meant to weigh humans would be able to pick up on that, because if it's too light, it doesn't show up on the scale. But the scales we have in lab they don't go up that high. They cap out at like 50 grams. So we need like something that's like in the middle, I guess. I'm not sure how much they weigh though. They're kind of heavy. I don't think they're more than like 1 or 2 pounds though. They're not that heavy.
Yeah. Well, why don't you, if you want to find something that you think could be locally procured at a Home Depot or something, if there's a particular product, just WhatsApp me or Discord me, whatever that is, and I can go ahead and buy it.
Okay, cool. Yeah, other than that, I was just maybe a bucket of some kind, like maybe a 1 gallon bucket, but I think I might have something like that in the lab. So that shouldn't be too bad. But my plan was to make 2 solutions of the PI. I was going to use the one that you purchased for us, and then also the other one to see how well they can wash coat for at least the monoliths that we have here in lab.
Yeah, let's be sparing with the PI that we have that I ordered for the not great Alibaba monoliths.
Okay.
Do some if you want to take a part out or something like that, but that should probably get us at some point back. We thought that amount, I can't remember where we found this out, was probably sufficient for all 5 monoliths that we can actually fit in the chimney, but certainly use some for testing. J3NX, by the way, just did recommend in terms of product types that might work for a scale of this sort. He said a jewelry scale or a cooking scale. So
okay,
Googling, if you find something that might be a good lead. Thanks, J3NX. Appreciate it. Okay, cool. The other thing that Kirsch did do in my WhatsApp with him is he said, he mentioned something about connecting with you. What would be cool is maybe if it works for him is like because we'll have the monoliths by then. Next week we're taking off because of Thanksgiving. Is that what would be ideal is the following week if we could have Kirsch on this call with you with monoliths in hand, him in monoliths in hand, and he just kind of talks you through, and it's like an ask me anything on wash coating and monolith treatment.
Okay, that'd be awesome.
Okay. If that can't happen, then we'll just set up another time that won't be on this call, and we'll just report back.
Okay.
He did offer that when he offered to. They're donating them too, so Many
Oh,
many
that's
thank
great.
yous to Clarity Technology for their help on that. Cool. I don't know. Did you know Tommy jumped off? Do you know if the sequestration team on Thursday, if they talked about their Wollastonite testing or their sort of plan for any of that stuff?
Oh yeah, they asked for some pH strips, so they were going to see if the Wassenite, I think it's if it goes from a basic solution or a basic pH, so like higher than 7 to below 7 to acidic pH, because when it captures CO2, it should form an acidic group inside the Wassenite. So they were testing that out. I haven't heard back from it, but I gave them a bunch of like pH strips that can they have gradients, so you can look from like anywhere between like 11 down to 7, so all the increments like 10, 11, 9, 8, all that. So I'm just waiting to hear back for that. I don't know how they're actually testing it. I'm not sure if they're just like throwing it out in the air and just letting CO2 diffuse into it naturally and see if over time it turns a different color for the pH strips or what. But they said that's what they were up to for the
Okay.
sequestration. Yeah.
What I'll do is this Thursday when I come. So next Thursday, as Tommy said last week, he'll start streaming in from the lab or the workroom, wherever the actual Epiphyte is. So we'll be able to actually point to our progress. And on Thursdays, I'll take pictures and videos and stuff that we can share on these calls. I will bring with me this Thursday my soda stream
Oh, cool. Okay.
with a couple of extra bottles, which we can use. It will be. Do you think there's any chance this is more of a software team? I wish there was a chance. We have to do a session on the CO2 sensors
Mhm.
and how to calibrate those relatively soon,
Mhm.
because it would be cool to kind of connect those into the sort of a soda stream apparatus with that bottle just for right now, for the purposes of, if we put a bottle on and we inject it with some CO2 and a little bit of solution in that bottle to be able to see what the ppm is,
Yeah.
and then to kind of play around with putting certain amounts of Wollastonite in. And so
Mhm.
maybe Thursday will be hopefully mostly a working meeting where we can go over, maybe have the mass transfer team just working on the heater, the fan, and the chimney, getting those operating, and then a plan for integration. Have the sequestration team sort of thinking through, okay, well, what are the parameters that how we are testing actually the reactions for the Wollastonite, and then maybe the software team is trying to get the sensors sort of up and running. Does that sound like, I don't want to dictate the agenda for that, but those are three like immediate areas of building that we probably should start with.
Yeah. Do you want me to write this down and maybe send it over to Tommy and Chaz so they have an idea too?
Yeah, that'd be good. I can also just write it into the Discord
Okay.
right now. Yeah, I'll just write those in. So those are the three things that we could do for that. All right. I feel like there was something else to talk about. Since Tommy had to jump early, we can jump in a little bit. But I don't know. Anything else, guys? Seth, any kind of questions, encouraging words, ideas? Again, I think next week again is holiday, but after that we'll be at sort of a different phase of showing what we've built and what we've learned, and I think it'll be pretty fun.
Yeah, I just have a couple random things. One is, calibrating CO2 sensors is not easy. So good luck with that. There's no really good, straightforward, tried and true method that is not expensive and hard. So we'll have to maybe come up with whatever we think is good enough.
Having a standard for that for projects would probably be a worthy and non-trivial
Yes.
effort.
Absolutely.
What is it actually like, both of you, and Seth, someone who's had their, was involved in the ordering of it and understands the problems we had with the last one. Like, what is it actually like to try to calibrate a device like this, the one that we have?
Yeah, there are different methods to do it. Whenever you calibrate, you have to have something that you trust as the ground truth. So that's either, what's often recommended is you dip it in liquid nitrogen, where you know there's 0 CO2.
Yeah.
And so that lets you establish a baseline, and maybe that's feasible in the lab. I don't know.
We do have that, so that'd be super easy for us.
Yeah, so that might be straightforward and easy. That's great for someone who has access, but as a general procedure like Christina recommended, it may not work for everyone. So that's an easy way to do it. The other way to do it is often to have a much more accurate, which means much more expensive sensor that you trust, and so that becomes your truth. And so you calibrate to that. So as a broader procedure, we probably need to have one that we would ship around the world to different groups. So that may not work either.
Yeah, I don't know about that one.
Yeah, and then there's keeping them calibrated, right? So you need to repeat the procedure periodically. I don't remember what it is for these sensors. I want to say for the ones we used last time, they recommended doing it like every 6 months or so.
Okay.
Seth, do you know how these sensors operate? Is it like a change in thermal conductivity as CO2 passes, or how exactly is it detecting CO2, if you happen to know?
Yeah, typically they use light conductivity.
Light, okay. Oh, is it infrared by chance?
Yeah.
Oh, okay. I think that totally makes sense, because CO2 is really good at absorbing infrared light. That's just like a greenhouse thing.
Yeah.
So that makes sense to me then. So if you are able to dip it in pure liquid nitrogen, because my thing was, if it's thermal conductivity, some of those sensors like that have to measure change in temperature as a gas passes through, and it can pick up some of the heat, so it can detect based off of the change in the temperature how much concentration you have of that given gas species. But it's not selective towards a given gas. It just says temperature change, so you have this concentration of something. Infrared is, I think that's probably good then. So if because maybe not even just pure liquid nitrogen, we could also, what if you had like a tank of or a clear bottle of pure gas, like pure nitrogen gas? That's super, I mean, not the easiest thing, or like maybe helium or something that doesn't pick up any infrared light, and you can use that as the standard.
Yeah, I mean, essentially anything will work as long as you know the concentration of CO2
right
in it. Right, and the easiest way to know is either 0 or 100.
Okay. So you could use a pure stream of CO2 somehow, like a tank of pure CO2.
If you were convinced that it was pure, yes.
Right.
We could probably bring.
Right. I mean, that's a reasonable way to get a pretty good calibration, right?
Yeah.
We don't need, right, for our purposes, we don't need super accuracy.
Not yet, anyway. Eventually, you'll want to be able to validate your system to within some standard, and it is going to be valuable to keep track of what your uncertainty is. But if you're starting with proof of concept, then you don't need to go that far yet.
Yeah.
Did you buy these sensors, Chris?
You guys have them.
Okay, sorry. I guess I'm not too.
You're on the chemistry side. Don't worry about it. But Tommy has them.
Okay.
We have a couple of different sensors. We have the new and improved one that we bought. They're both Sensirion, and then we have an older one that Tommy already had, which was the one that we used for the first project. So I think, Seth, for the purposes of testing out the wollastonite, where there's not like a lot of airflow that's happening consistently, we might want to just use that simpler one that we initially had for the purposes of the wollastonite testing. We'll take a look at it on the table when we get there on Thursday. I'll make sure Tommy brings those and just look at the paperwork and just kind of level set about what do we know and not know. We'll look at the code that David did for the last one and see if we can just get some kind of simple way that we can have readings appear on a screen for the wollastonite team. Because again, what they're going to want to do is they're going to want to know how much CO2 they put in the bottle with the wollastonite, and then see how it changes over time, which will tell us as it goes down, the ambient CO2 means that it's being mineralized, presumably. So we'll have to just figure out some kind of practical method of doing that. Go ahead, Christina.
I was going to say, I feel silly saying this, but I feel like a soda stream might not be the worst kind of hacky standard. I don't know if anybody's quantified it, but that's something, I've got one. It's a fairly accessible thing. It's consumer grade. People can get them. It's somebody at SodaStream has made that relatively repeatable. And obviously, when you put the canister in, there's sort of this curve, right, that must exist where it starts to get tired over time as it runs out. But I wonder if anybody has calibrated that, because you could use that as your sort of very low fidelity calibration standard that would be really easy for people to get their hands on and say, okay, I know this is probably in about this ballpark.
I know to ask too, Christina, because there was one thing, if you remember, like over a year ago, we had this little competition with 3 different teams. One was UT, and they actually hacked the SodaStream for their sort of cyan hack. But my idea around that was, I was a reviewer for the X Prize Carbon Challenge, and I had to review about 20 different things for like a first cut. And there was a lot of video, and one major direct air capture company, who I won't name, that was on there, in their videos, they were using a SodaStream exactly for this very purpose. And I know the guy who they had as their validator is actually a friend of mine. He's one of the leading mineralization experts in the world. So I could probably ask him about how to use a SodaStream for this purpose. So yeah, I love the idea of it. It's very
I would be really curious to hear back, because that's something that could be a feasible calibration standard for people. And again, it wouldn't be terribly high fidelity, but for just a proof of concept validation, that might really be a good way to go. We could just write that up and put the numbers out there. So what we would need is somebody who has the sensors and the background in them to basically be the cal lab for that as a project, and then also to figure out if there's a range of soda streams. But like I have an older model, and maybe it's changed. I don't know. So I'll be really curious to hear what your contacts have about it. But yeah, that seems like a worthy enterprise.
Yeah, cool.
It might be worth reaching out to the SodaStream people to see if they've done any testing on.
That's
on
true. They might get a kick out of it. They may not want to share, but
do they sell their own little cartridges of CO2? I'm guessing.
Oh yeah.
We do, yeah.
Okay.
Yeah, you can go to a Target, exchange your depleted one, and then they give you a new one.
I have one. I'll grab it.
Huh. Yeah, it's right here. Actually.
I'm just wondering how pure that CO2 is, because I'm guessing it's pretty dang pure, but there could be like air in it or something potentially.
That's it right there.
Oh, that's a big.
It
says
says
60 liters.
CO2, CO2 cylinder.
Wow, that's huge.
We could probably find out how pure those are.
Yeah.
How much does one of those cost from Target to refill it?
It's like $19 or something like that.
Okay, that's not bad. Okay.
I bet SodaStream has had to quantify their purity for some certification.
Sure.
They've got.
Mm-hmm.
They actually sell. They market that in their CO2 supplies, that it's from like post-industrial sources. They have some
that's cool.
environmental thing that
that's cool.
Using.
So the other question I had, Chris, do you think we need to retrofit one of those like soda bottles that goes onto the machine to have the sensor like placed? Yeah. So okay, how would that work? I guess to make
we could probably drill a hole into the side of it and seal it up, and then have the sensor head go. This is not going to be high heat for like just for this basic testing right now. They will want to do heat eventually, because that's one of the parameters. We want to actually have it a little bit hotter than even the
I would go for the cap, actually, because the thing is under some degree of pressure, and you wouldn't want to compromise the bottle, and then you'd get leaks. But if you had like a thing with the cap, you could just the cap's the standard size.
Yeah.
And so then you could have your like regular cap and your
Yep.
And that way
the CO2 through, is it the bottom or the top?
That goes through the top. You mean when you put it in the bottle?
Yeah, on the machine. Does it?
Yeah, you just
you take the top off. You fill it with water up to a line, you screw it in. So you'd want to use distilled water for this, presumably.
Yeah.
So you screw it in, and then you hit one of 3 buttons, which are fizz, more fizz, and yet more fizz. I don't know. I'm sure there's a number associated with them. I don't know what the number is, right? And then that's how many times it applies CO2 to it.
Oh, okay.
So
yeah, it does these pulses of like, and when you first get one, as you probably remember, Christina, it like blows up in your face because you don't seal it too tightly.
I actually, yeah, exactly. There's a little bit of a learning curve.
Yeah. That will be good. I'll bring this with me.
If you leave it without any liquid in there, does it can still do it, right? It just fills up the canister with CO2.
I did do that. It starts to get kind of, you sense something's happening in terms of pressure, and you see like a little bit of, usually there's a little bit of moisture in it, so it'll become slightly more opaque. But we have to put liquid in it anyway. So like there's whole nice like test here where they want to figure out what's the proportions of water to wollastonite. They can go ahead and just stir that in there. Where it would be interesting to just see if like we had half, just fill it up halfway or something and put the right proportions of wollastonite in and stir it in. We could even like sort of shake it up a bit so it's well distributed and then do it. But I think Christina's right. You can either put it on the top of this guy, but there's also, this is an interesting little thing here, like on the bottom, it has like, you can't quite see it, but I'll bring it in. It has like, I don't know. We'll figure it out, but I think she's right about that this is the harder stuff here that we should probably connect the sensor to, so we don't compromise that. But there you go.
Oh, okay. Sparkling water. Nice.
Yeah.
This conversation is making me crave it. What can I say?
Yeah.
But
I still badly wish we could find out a way that we could actually hold up that, unless you probably just brought it back, but the CO2 tank, like if we had some kind of way that the CO2 that's just sort of nicely flowing out of the DAC unit, like I wish we could compress that in some way so we could actually hack a soda stream to press the button and then shoot the CO2 out.
That'd be cool.
You could look at the electronics and hack the electronics of it to probably automate it and stuff like that. But that's the one.
Use it as a dispenser that way.
Yeah, that's one thing we haven't. I don't know. That would be very cool.
Somebody must have taken one apart. Does yours have a little mark on it that says 840 milliliters?
Yeah.
0.89 quarts.
Yep.
Okay, so the size of the bottles probably hasn't changed.
No, they're all uniform. So
yeah.
But
so if we use this to calibrate the sensor, would the bottle have to be evacuated and have nothing in it beforehand? Because there's air in the bottle and then CO2 comes in, so there'd be, I don't know, it wouldn't be a good calibration in that sense, right? Because there might be extra CO2 from just air being in there already. I'm just thinking of what some issues that might pop up.
No, it's a valid question. I mean, you're gonna see some variation regardless. The question is like, how significant is that? Because it's pretty well mixed, in the atmosphere. So like, it's probably not going to be a big margin of error on top of what you're putting in the bottle.
Yeah. Oh, I guess we could always do CO2, like the soda stream, and liquid nitrogen, both, and do as a comparison, see how the reference looks like based off of the two. That'd be a good test.
Yeah,
we try that.
I have 4 of these, 2 of which we never use, so I can bring a couple of them. I just have to sneak them out of the house without my wife beating me over the head, because that's a household asset we do use. But we can, for the cause, use it for this for a while. Yeah, it would be. I wonder, what do you guys think? Like, since we've been talking about vacuums and stuff, I know that sound. You definitely hit the 3 dot. I could identify that, Christina. That's a highly carbonated seltzer you got there.
Oh yeah.
But it would be interesting. Like, can you do something where we could pull the CO2 out into could a vacuum chamber be high pressure enough to where we could rig it onto the back of this, where we get the vacuum chamber with the CO2 high enough pressure, where let's say we figure out a way to connect it to the back where the tube normally goes, that would allow us to press it, and then it to be go to do that.
The pump, whatever pump we end up getting could be strong enough potentially to pressurize the chamber. I think that could be true. The other thing too, I know we're not even on the step to buy the pump yet, Chris, but whatever pump we do get, we have to make sure it's oilless. So it can be whatever style. It can be a diaphragm pump, rotary vane, whatever, but it cannot have oil, because if it has oil, that will escape through the exhaust with the CO2 and then just mess up everything inside the tank potentially.
I'm glad you told me that, because I was looking at ones and ones I was looking at all seem to have oil. So if you have one that is, Christina, did you just say no when we were saying sort of using a vacuum chamber to like?
You asked if I understood what you were saying, and I said no because I didn't.
Okay, good.
I followed along, Chris. I know what you're saying.
But imagine if we could do that, because there's these little vacuum chambers from that same company that I was looking at. Remember a while back with the looking at those like anyway, they're cheap. They're not a lot of money. They're like $100.
If it's small enough, it'd be easy to pressurize with the whatever pump.
Oh my God, imagine that, how awesome that would be. So you see what I'm saying? So we had a tube that was passing through this guy. Jesus Christ. If we had a tube that instead of this thing here, if we had a tube that goes into it, and we have our DAC unit, we have the vacuum chamber, and then we have a tube that goes into the back of this.
Mm-hmm.
The pressure in the chamber was high enough that we could actually press a button and it would go.
Chris, does it say how much PSI is on the CO2 cartridge that you just took out?
It says, I don't see it, but we could probably look it up online.
Okay.
What do you think we would need?
Oh man, I don't know. I think really there's a certain threshold you have to hit for pressure for it to be able to just like shoot out on its own. But I think those are really highly charged, so the PSI is probably pretty high, so you can just keep reusing it. But if we wanted like maybe a 1 or 2 second injection, you can have whatever pressure inside there that's above that minimum threshold to just be able to shoot out on its own. We don't have to like supercharge or super pressurize the chamber to have like a continuous stream all the time. It could be little spurts, right? But there's like a minimum, which I'm not sure what that would be. So I'm just wondering what the little cartridge PSI would have.
Okay, it says that it's holds a pressure between 830 and 860 PSI.
860 PSI?
Yeah.
Inside the little cartridge?
This thing here?
Yeah.
Yeah.
Whoa.
It's sold by weight, and it's going to change as it empties.
Okay. Oh, okay. That's a lot. Well, you know what? It said 60 liters on the side there. I don't really understand how these units work because clearly that thing is not 60 liters, but it's saying it holds 60 liters of gas. But I'm just like, what does that mean? Like when it expands out into
presumably at STP, right?
Yeah, but I don't know. It's just a strange, like weird way of describing them. It'd be nice if it said moles of CO2, like how much or mass of CO2 that was in there. That'd be the best way to look at it. But yeah, that's like really pressurized in my opinion. That's almost dangerous, I think. But I guess not. Maybe it's strong enough to hold that.
Yeah, I'm just looking at this thing that I have for the vacuum chamber.
Oh, you know what I just realized, Chris? I think honestly all we have to do is get above atmospheric pressure, which would be 14 psi, 15 psi roughly. And if you can pressurize a chamber to anything above that, you'll probably have a stream of CO2, maybe not super long, maybe like 1 or 2 second, like little pulse. But if you can pressurize it using a pump or whatever that's putting CO2 into it, then it should work. You should be able to
you just need a differential, basically, right?
Yeah, whatever's that. Because whenever you stick the bottle on the other end of the soda stream, that will be at atmosphere. So that'd be 14 psi. So if you can beat that, then you'll start pushing CO2 into it.
Okay. Yeah. However satisfying it is to hear it go, like it doesn't. We don't need to go that crazy with it as long as there's some difference. But let's think about it. I'll bring these here. We'll have them on the table. We'll break up into groups. We'll have a team that's sort of thinking through how we might be able to hack that. But yeah, that would be so hilarious too. That's like so hacker if we give a soda stream new life to deliver our CO2 into the mineralization.
I think that's really cool. I think that could work. I think it's cool.
That'd be sweet. All right, cool. Well, lots to think about. That was a good little sesh there. So I'll see you guys in tomorrow night. We'll take some pictures and crack open the GitHub, make sure all our tasks are are accounted for there. But yeah, excited to kick off the build tomorrow.
Do you guys have a Box folder or a Google Drive folder or something where you're keeping your design files?
Ooh, I should have asked some. I think we do have a box, but I have to talk to Tommy about that. I haven't looked at it closely. Yeah, but there should be something.
Start putting those things on the GitHub, because right now all it has changed on there is somebody added some notes as a file and then deleted it.
Oh, okay.
So
Okay.
the GitHub is not reflecting anything that you guys are doing.
Yeah, I think what we'll do, I'll be the GitHub cop, and we'll try to really, now that my son's soccer season is over, I can make these. So I can make sure that at the beginning and end of sessions that's where we sort of reconcile, does the GitHub reflect where we are? So
Excellent.
I'll take that on myself to do that.
Thank you. All right,
guys, this is great. I'll see everybody. I'll see you guys tomorrow, and then everybody have a good Thanksgiving. I'll share the pictures on the Discord as well, so you guys can see what happened yesterday and where things stand. But we'll pick it up after Thanksgiving.
Cool.
All right, guys.
See
See you later.
Bye.